Today we are going to discuss about beats and then we will discuss about Doppler effect. First of all, let us know what are beats. Beats are a special type of interference of two waves of slightly different frequencies. But of course, we can hear these beats if the frequency difference between the sound waves is nearly less than 10 or so. What actually means beat? That is rising and falling of sound intensity at regular intervals of time is known as beat frequency, or that is known as beat. So the number of times the sound becomes maximum or minimum in a second can be considered as beat frequency. This is just like your heartbeat, but here the difference is that the amplitude of the waves, resultant wave, varies periodically with time. So that's why we say it is a special type of interference at the same point due to overlapping of these two sound waves or two waves of slightly different frequencies. The amplitude of the resultant wave changes periodically, and this is known as beat phenomena. So let us derive a mathematical expression for beat frequency. Let us consider two sound waves. So let S1 be represented by A cos omega 1t, and another wave with slightly different frequency is represented by A cos omega 2t. And you know what are these omega 1 and omega 2. Let us suppose omega 1 is slightly greater than omega 2. Now when they overlap, the resultant wave is given by, according to our superposition principle, so A cos omega 1t plus A cos omega 2t. Now here we can apply the trigonometric identity, that is cos A plus cos B. So which gives cos 2 cos A minus B by 2 cos A plus B by 2. Of course, we can take sine functions also. The final result will be same, but we are considering sound waves which are longitudinal waves. That's why we have taken the cos function. Now applying that, we can write like this. So the resultant wave is given by 2A cos omega 1 minus omega 2 by 2 into t, and cos omega 1 plus omega 2 into t. In this is the amplitude part of the resultant wave. So the resultant wave also is a periodic wave, and for the amplitude to become maximum, that is this cos value omega 1 minus omega 2 by 2 into t can take plus or minus 1. In such case, the amplitude will become 2A. So to satisfy that condition, we may write like this: omega minus omega 2 by 2 into t must have values which are some number n, 0, 1, 2, 3 like that. So where n takes 0, 1, 2, 3 like that, so it should be a multiple of pi. So then we can write like this: 2 pi, let us suppose mu1 minus mu2 by 2 into t is equal to some n number of times pi. Here this pi gets cancelled, 2 gets cancelled. Then what remains? So your this frequency term difference mu1 minus mu2 is equal to n by t. So n is a whole number. So let us take n is equal to 1. Then mu1 minus mu2 is equal to 1 by t1. And for n is equal to 2, this mu1 minus mu2 at some other time is t2. So from this implies t1 is equal to 1 by mu1 minus mu2. And here is 2. And from this implies t2 is equal to 2 by mu1 minus mu2. Therefore, from these two equations, that is this one and this one, the time interval between the first time amplitude becoming maximum and second time amplitude becoming maximum, that can be written as, that is t2 minus t1. So, which is nothing but some delta t is given by 2 by mu1 minus mu2 minus 1 by mu1 minus mu2. So, therefore, this is equal to nothing but mu1 minus mu2. So, the time interval between two maximum amplitude, successive amplitudes is given by this. Therefore, this reciprocal of this period for the amplitude to become maximum is equal to mu1 minus mu2. And this reciprocal of period is known as frequency. So, this is the frequency of the beat. It means the sound can become maximum so many number of times in 1 second. For example, you have two waves, one with a frequency of 9 Hz and another say some 11 Hz. So the difference is equal to 2. So the difference between them is 2. Therefore, in a second, the intensity of sound becomes 2 times maximum and of course 2 times minimum. So, one maximum and one minimum, we can say beat just like that. So, lub, dub, so like that. So, when two sound waves traveling in the same direction with slight difference in frequency overlap, the amplitude of the resultant wave varies periodically, and this waxing and varying of sound intensity is called as beat phenomena. So, that's about the beat. And this is the mathematical analysis of beat frequency.